Just over here, and we are going to talk about how to calculate the molar masses of chemicals. Okay. Obviously, if you were going to calculate the molar mass of a single atom, that is always given to you right here in the atomic mass unit. In fact, the atomic mass unit, and the molar mass are the same. The only difference is that the atomic mass unit has a unit of a gram, and the molar mass has units of grams per mole. That's the only difference. Same thing. So if you had, let's say for example, you would round this. So if you had two of these, you would have, if you had two rutheniums, if you had two rutheniums, you would have a molar mass and an atomic mass of 202. You just add, just simple, 202 grams per mole for molar mass. So that's for single elements, but I want to go through a few of the ones for chemicals. So let's do it. So this is how you do it. Take that off. You basically say, okay, I've got chlorine, Cl2. In fact, this is a great example of what we just did. Chlorine, Cl2. It's basically saying I have two chlorines. So I just take the atomic mass, which is also the molar mass, and I round it. This is going to be 35. So I'm going to do 35 times 2. And so I have, for this one, this is going to equal 70 grams per mole. All I did was add up, or in this case, I just multiplied by 2, the 35 by 2. Let's do KOH, which is potassium hydroxide. And so we're going to go over here. We're going to find our potassium. And our potassium has a molar mass of 39. We're going to round it. Okay, so we got 1 potassium, we've got 1 oxygen, we've got 1 hydrogen. And so we're just going to write this down, 39 for potassium, oxygen, and hydrogen. 39 plus oxygen is going to be 16. We're going to round that. So it's going to be 16. So plus 16. And then we're going to go find hydrogen. And hydrogen, we're going to round it to 1 plus 1. So this is pretty simple. The potassium hydroxide has a molar mass of 39 plus 16 plus 1. And that is going to give us a molar mass of 56 grams per mole. Simple. Let's do a few more. So, say for example, let me erase this because I usually forget to erase everything I'm doing, and then I have to do it later. All right, so we have beryllium. We have 1 beryllium and 2 chlorines. So we have beryllium, and then we have chlorine. Okay. So let's find our beryllium, and our beryllium is in the alkali earth metals right here. Alkali earth metals, second group, and it has a molar mass or an atomic mass of 9.01. We're going to round it to 9, so that's going to be 9. Ooh, that's a gram. What you doing, boy? Let's change it. 9 plus chlorine is going to have a atomic mass of 35. We just did that one earlier. So 35, and we're going to round it. So 35, and this is going to be 2 times 2. So this is going to be 9 plus 35 times 2 is going to give us 79 grams per mole. And this is the molar mass of beryllium chloride. Let's do some more while I erase. We just get reset. Boom, there we go. Let's do iron chloride. So we're gonna find our iron. We have 3 chlorines. So right here we have iron, and then we have chlorine. Let's do this, chlorine, and that's gonna be times 3. But here's our iron. Here's our iron. Let's do a different color here, just because. Here's our iron. We're gonna round this up. So this is going to be 56. 56. And then chlorine, we just did that up here, which is 35. 35. So that's going to be 56 plus 35 times 3 because of this 3 right here. So let's do it. Cancel. So it's going to be 56 plus 35 times 3. And that's going to be 161 grams per mole. And that is the molar mass of iron chloride. Let's do another one, just so that we have this completely understandable. So let's go over here. So we're going to do boron trifluoride. Boron trifluoride. Remember, that's a covalent bond. And so you have to add in the prefixes. But if you only have one, you don't have to put mono boron trifluoride. Nope, it's just boron trifluoride. So we've got boron, and that boron is right here. So boron is going to be right here. We're going to round that up, and so that's going to be 11 plus 3 fluorines. There's that 3. Ooh, let's take that off. 3. You see it, the 3 right here. And then the fluorine is going to have a rounded up. It's going to be 19. It's right here. 19. 19 times 3. So let's do it. So this is going to be 11 plus 19 times 3. This is just simple math on a calculator, and that's going to give us 68 grams per mole. And what that means is that there are 68 grams in every 1 mole of boron trifluoride. That's what that is. Let's do this one. This looks a little complicated, but it's really not. We've got 3 elements here. So we've got, I'll just do this one in blue. We've got carbon. Then we've got chlorine, and then we've got fluorine right here. We've got fluorine. So let me take this one right here. That way we can see our carbon. Make it blue. Okay. Sorry. Okay. So now we have carbon, chlorine, and fluorine. So we have 1 carbon. So that's going to be right here. It's going to be 12, rounded down. 12 plus chlorine. Remember, chlorine is 35. It's right here, 35. We rounded it down. So that's going to be 35 times 2, because we got this 2. And then we have plus fluorine, which we just did, which is going to be 19 times 2. So again, simple math. Let's do it. So we take our 12 plus 35 times 2 plus 19 times 2, and that's going to give us 120 grams per mole. And again, what that means, for every 1 mole, this carbon and chlorine and fluorine right here is going to have 120 grams per mole. Does that make sense? So 1 mole of that will always have a mass of 120 grams. Let's do one more. Magnesium hydroxide. Magnesium hydroxide. Erase this. In fact, I'm just going to shrink it and erase everything I've done. So we're going to try to find the magnesium. Magnesium is going to be over here in the alkali earth metals. Alkali earth metals. It's going to be 24 because we're going to round this down. It's 24,305. So this is going to be 24 plus we have 2 oxygen. We have 2 oxygen because this distributes in. So we got 16. I'll show you where I got that from. Oxygen is 16 right here. Okay, 16. And that's going to be times 2. And then we have 2 hydrogen plus, and hydrogen is 1. So that's going to be plus 1 times 2. And that's going to equal out for us. Let's do it. 24 plus 16 times 2 plus 2. And you don't have to do the times 2 on the hydrogen. You can just figure that out. So that is going to give us 58 grams per mole. And what that means again is for every mole, one mole, you always have 58 grams of magnesium hydroxide. All right, so that was molar mass and how to calculate it, and hopefully that helps.